Alright everyone, welcome to week 6 of CSE110 or Intro to Programming in Python, whatever you want to call it. Now, jumping right into it, this week you have something called books.txt. Now, if you're not actually going to class at school, you obviously won't have this. You can literally just make a txt file however you want, fill it with a bunch of stuff, or I'm gonna put this in the description. You can just copy paste it in there, make yourself a books.txt and put it in there. But if you are at the school, they're gonna give you this file or these things, or give you these names or whatever, and want you to put it in a file that is along with your prepare file or whatever you want to call your file. And the objective here is to open the file, print it all out, and then just close the file. So I've opened it up here in this. There's a couple ways you can do the open mechanic to open the files. The one I chose was just this open. There's other ones called like open with or with open. I can't remember which way it goes. Things like that. But here I just called a variable books equals open, and then I opened this file. I now had to put the entire destination, the entire file, the file path is the word I'm looking for. I had to put the entire file path. I initially tried to just put books.txt because it is right here. So I know that books.txt is right here. And so I tried like /books.txt to try to get it to recognize that that's there, but it kept telling me that it didn't find that file. It couldn't find it no matter how many different ways I wrote it. So eventually I just wrote the full file path from this the hard drive that I have, this HDD that I have, and then the file path where it goes. Sometimes you have to do that. Now this is in my my OneDrive. If it's not in your OneDrive, it'll be somewhere else, but wherever it is, you can type it in that way. Now, if you run into the same issues of you can't just type .books or .books, now you shouldn't need to do that, but .books should work, and everywhere I've read it has worked, but for some reason I couldn't get it to find it. It kept saying it doesn't know where books is, so I had to do the full file path. And if you run into issues like that, just know that you have to put in the full file path. Another quick note is don't forget that these slashes need to be forward slashes, not backslashes. Sometimes as you go through your file path to try to find exactly where you are, you'll see them as backslashes in Windows. You don't want that. You want them as forward slashes, or else the program won't run, because backslashes are a symbol in Python to mean kind of ignore the next bit. So as I was like showing you before, if I decided to put right here like \n or something, if I was saying print this and then \n, it's saying new line. So this backslash is telling it to ignore the next piece as part of the text, because it's not. It's just a new line character. So the backslash plays a role in Python and you can't use it here. So make sure they're all forward slashes so that it can tell that's where you're going. Another way you could do this is if you wanted to, you could say, you could scoot this down and you could say like file path is equal to, and then just copy this and put it right there, and then all you have to put here is just file path, and it works the same way. It's just shoving that in there. It just looks a little bit cleaner. If you want to do it that way, that's totally fine. The R stands for write. Read. Stands for read. If you wanted to write something to a file instead, if you had that in mind, you could put a W there, but we are just reading the file, so we want to stay in R. So what we're going to do here is we're going to create this for loop for I am books, and then print I.strip. Now .strip, all that does is that takes away the leading and the ending white space. So if someone had, let's go back here to books real quick. Books.txt, if say down here at the end of here that someone had like a space, or they had a tab, that's white space. There's space there that you don't want. And it can mess up your program sometimes when you have those in there trying to read it and stuff. So .strip will just take those away before it prints it, and then prints it without them. And we can go ahead and run this so you can just see what it looks like. If you run it, it'll just print all of your things in your list. So you see why I just say, like, if you want to make your own and fill it with a list of stuff just like this, go for it. Like that, it'll do the exact same thing. But that's how you do that. Now, it's always good etiquette to remember to close your file once you've already opened it and ran through it. Closing it's important. That tells the computer to no longer allocate memory to it. And if you had a bigger program that would run for quite a while, for example, if we had that adventure game that we did a while ago, if you had that adventure game and you wanted to and the game kept going for a long period of time and you didn't close a file that you had opened, it would still be allocating memory on your computer for that file and holding that file for you because it assumes you're not done with it because you haven't closed it. Actually, in some cases, if you have a lower end computer, a lower end laptop and things like that, it would make it run marginally slower, much slower, because it's just allocating extra memory that it just doesn't need anymore. So it's always good practice that when you're finished with your file that you do close. In this case, since I called it books to begin with, books.close. Now in this file, it wouldn't make it any slower if doing this, because once it's finished printing the last thing, it will just finish up and it'll just close the program and then it'll finish that. It won't allocate any more memory towards that anymore because the program's done. But if you were in a bigger program, you got to make sure to put this when you're finished with it, or else it'll keep that memory available for that. It makes it run a little slower. Now for Prepare 2, they want you to create a string of people with a name and an age right after it. It looks kind of like that. I just copied that, pasted that from what I have. And so you create this person and an age, and you do this in strings because they wanted to teach you how to use a split method or a split function. Now split is a function that exists in Python already. Now how that works is you have this list and you need to go through that list and break apart the string into pieces. Okay, so you have for loop, for person in people. So person is your variable that you're going to use. You just created it to go through the people list. And for each person in that list, the attribute, this new thing, you can call that whatever you want. I called it attribute just because that was the first name that I could think of. But attribute equals person, this right here, dot split. Now I've left it blank. There's nothing in those parentheses, which just means that it's going to take all the spaces and that's what it's going to split by. Now if you had something else, if you had like a CSV, for example, there's life expectancy right here. It's a CSV, which is an Excel file basically. It stands for comma separated values. If you have a comma separated value, let me go over here real quick, you see, it has commas in between each thing. They're not spaces, they're commas. And so if you have a CSV file like this, and you were going to do something similar to what we're doing here, instead of saying split blank, you would put comma, like that. That's telling the computer that it's looking for commas, and every time it hits a comma, it needs to split the line. But for this, we don't have that. Remember, it's just spaces, so we can just leave it blank. You could also, you could also do that to tell it specifically that you're looking for spaces, but it's unnecessary. You don't need to. So what's happening now is it's turning attribute, this new variable that we just called, into a list of index 0 and 1 over and over and over again. So this is attribute. When it comes through here and it assigns attribute now has two values in the list. It's got 0, index 0, and index 1. It's these two. And then when it loops again, it'll go to John, and it's got index 0 and index 1. So what you can do here is I created these variables here that I can manipulate and run around with, like the oldest age, because you need to find the oldest person and the youngest person. So I got the oldest age and the oldest name. That's how I started out. We'll get to the younger part in a minute. But oldest age and oldest name is blank. And as you come through here, you say if attribute 1, which is the age, if attribute 1 from what we're looking at, so if we come here and we look at attribute 1, there it is, if that is larger than the oldest age, which at this moment is 0, then oldest age now becomes an int attribute 1. And then you want to take also the name of the person, oldest name, to say like the oldest person's name is also equal to that. So oldest name now becomes that attribute. Now what this does is each time it loops through, it's going to keep checking. So it's going to start with Stephanie. It's going to say 36. Is that greater than 0? Oh, it is. Now make sure we copy Stephanie and the 36, and those go into these two values. And then it loops again. It goes to John, 29. Is 29 greater than 36? It's not, so it just skips it and moves on. It keeps going and keeps going until it hits one that's larger than that, which doesn't look... Oh, there's 54. So there's one. So once it hits 54, it thinks, is that greater than 36? Oh, it is. Now override it so that it's no longer 36. It's now 54. And then Gretchen takes over as the oldest name. So in the very end, when you have this print statement, the oldest is oldest name, and then age, oldest age. It'll say Gretchen 54. With that same idea in mind that you just want to reassign that variable again if it happens to be larger again the next time, you do the same thing with the younger one. Now we know, for this example that I'm using here, we know that no one is 200 years old. Like, I mean, the last time someone was 200 years old, we know that was just Bible times. Like, they hit like 800 and, 900 years old. Like, that was crazy. But that doesn't happen anymore. No one makes it to 200. So in this instance, I feel pretty safe putting 200. There's also a math thing. Last time we talked about math stuff. There is also a math dot infinity, or INF, yeah, math.inf, and I think it stands for infinity. There is that as well. You could use that. I've seen people do it for this assignment before. So that youngest age is infinity because you're starting at this very far end so that you can check if something is lower. But I just went 200. Felt like it was pretty simple. And again, youngest name. So then the second if will constantly, as it goes through, check the youngest age as well. So as we did before, we come to 36 is Stephanie, greater than 36. It'll say yes because that's the only number we know so far. So 0 is greater. And then after that comes to this if statement and says if attribute 1, which is still the age, is less than the youngest age, which it is. 36 is less than 200. Perfect. Then it takes the name and the age and it saves it. It overrides it into these two variables right here. And it does that every time, as before. It keeps going through and checks for the oldest person and the youngest person with these two if statements each time. And then at the very end, it'll print those statements for us. It'll print the oldest and the youngest. So if we hit play, we will expect it to say the oldest is Gretchen, 54, and then say the youngest is 2, Michael. So Michael 2. So the youngest is Michael 2. So if we hit play and see what happens, we got the oldest is Gretchen and the youngest is Michael, age 2. So this is what we get when we run this kind of thing. Now remember, split does it on the spaces because we told it to. This comes important when we move to the team assignment. Now if you're not at the school, you're not going to have the team assignment unless you just want to do it. But for the team assignment, they gave us this thing called HR system. An HR system looks like this. For the team assignment, basically, they're going to give you a bunch of things that you can try to do with it. It says just separate all these first of all, like we just did. Make sure you do the dot split, and you make sure it's by spaces. And then you can assign these values to a variable, to different variables, to make sure that you can hold them. The same way we just did here, where you would say like attribute or something. Attribute equals person.split. Or whatever we would call it, because we have people, but you have to load the file the same way you did prepare one. So you could load it like this, and then books would be the one. So you do books.split, but you probably would call it something different. So you need to divide up all this stuff, and then you need to assign them to different variables like we did here with attribute, and just say oldest age is equal to that. And then in the class they ask you to do a bunch of stuff. They ask you to say, can you find all the engineers and only print the engineers? Which we could do that with a couple of for loops and such. We could just say if the name is equal to engineer, print it, otherwise don't. That part is pretty simple. There's other ones. If you make these into numbers, they say only print the people with the salary higher than whatever they said. I can't remember the exact requirements right now. But again, you just do that by making these variables numbers and then just keep checking if that number is greater than whatever variable they said, and then print it if it is. So that one's not too hard. It's just a cool team assignment you guys can do together. For the final proof assignment for this week, you're going to get this file. Now, if you're not in the class and you really want to have this, I guess I can have it available for you. I can put it in the description, I suppose. I might just put the files themselves rather than putting the text. So you guys can just download the files directly. But here's what it is. It's a CSV like I was talking about before, and it is comma separated. You have commas separating your values. And there's another curveball, which are these right here, these titles up here. And so for your proof assignment, you're going to want to first load in this file, and you do it the exact same way you did here in Prepare 1. And in the team assignment, you could do equals open, you could do the open with, or however many other ways. If you Google how to open files, you'll be able to find many ways to do that. But you want to open the file, and then you first need to ignore this first line. Now, there is something in Python called .next that our teacher talked to us about this one time. If you called the file, I don't know, file. Say we loaded in this file and we called it file. Okay, so we got file. You'd say file.next. That syntax to say file.next, that will just skip your first line. If you do like a for loop where we were talking about before, right here, if you do a for person and people and you just said person.next or something, and you could force it so that it would just skip your first line using this method. Now the way that I did it was I just did, because I didn't know about the .next, so I did something like, it was like for I in file, and then I just did like a whatever it was. I did like counter is equal to 0, and then I did for I in file, and I said if counter is equal to 0, then I did like pass, and then I did else, and then I just typed in oh, I don't need those, oops. Then I did else, and then I just typed the rest of whatever else my code was to treat the information with what I should. But if the counter was equal to 0, and then you have to go counter plus 1. So that's what I did. I did counter plus 1. That way it would never be 0 again. But it would only be 0 the very first time that it goes through the list. And it goes through this list. So it would just skip this line. That's how I did it. It's kind of silly, but that's how I got that to work. So lastly, the thing, you can tell that this is a really long file. It goes on for ages. It's really large. It would take forever to parse through that manually. Now, remember how last time we had to find the greatest number or the oldest person, the youngest person, all that, whatnot. You're doing the same thing here as part of one of the assignments. One of the assignments for this information that you have here is you want to find the average life expectancy of the whole thing. So the average life expectancy of this whole file. So you're going to try to do the overall minimal life expectancy and the overall max expectancy, which you already learned how to do. It's not too hard. Just remember, you just need to go through the list and search to see, is this one higher than the previous one? Oh, is it higher than the previous one? And with the max life expectancy, you want to start like 0, for example, or the minimum life expectancy, you could start at 200, you could use infinity. I started at 200, I'm pretty sure, because I know that no one's going to make it to 200. They also ask you to do an interest year. They want you to check if a person can enter an interest year, say what year they're interested in, and then it prints back out and tells them for that year, what is the life expectancy and such. As you can see, you have a spot named year. It's this one right here. It's a little offset, but there you are. So you do it basically the same way. All I did was I just created a variable. You know, I said, where's my practice? I said something like, interest year is equal to input. What is the year of interest? And then all I would say is, if the year that it's going through in the for loop, you know, for I in file, and it says if the I, or whatever we're parsing with, the year is equal to the interest year that the person put in. In this case, you want to find the average, so if the interest year that they entered is also equal to the year that it's looking at in the line of the CSV, then you need to add that life expectancy to some, like a sum of numbers, and then keep a counter going so that you could say this sum of all these numbers, life expectancies, divided by however many life expectancies there were. Hope that's making sense. That's how you do averages. So if you're looking for 1996 and there's only 3 of these entries in life expectancy, 3 entries that are in 1996, then the counter needs to count 1, 2, 3, because you're going to add in the life expectancy for 1, 2, and 3. You're going to add the life expectancy of those 3 instances, and then you're going to divide that number by 3 because there were 3 entries. So you need to know how many entries there were. So that's why I would create a counter, that each time you add a number into the sum number for this average, for this interest year. But that's everything for the base requirements. Now you have to do your extension. What do they call those? I can't remember. When you take one more step, you do a little bit more. You add something extra to the file. I added an interest country as well. So I did basically the same thing as an interest year. I just did an interest country, and it would tell me the overall life expectancy of the country inside that file. So that's what I did. But go have fun with it. If you have any questions, let me know down below. I will try my best to keep an eye on them and be there for you guys. So until next week, friends. All right, I'll see you.